To address the motor fan direction issue, especially when one fan's operation influences the other's direction, consider the following capacitor adjustments and circuit configurations. Firstly, to boost the start torque in the desired direction, increasing the start capacitor value is crucial. Try replacing the existing 10 microfarad run capacitors with larger values, such as 15 or 20 microfarads. This modification supplies a greater torque during the initial startup phase, potentially ensuring the fan starts in the correct direction. Secondly, it is possible to use a start capacitor to aid in starting, even within a run capacitor circuit. The start capacitor should be wired in parallel with the run capacitor, but only for a short period during startup. This temporary parallel connection offers supplemental torque. After the motor achieves the specified speed, it is essential to disconnect the start capacitor using a centrifugal switch or a contactor to prevent damage and ensure proper operation. Now let's discuss how to size capacitors accurately for motor applications. When it comes to run capacitors, a general guideline is to choose a capacitor value between 1 and 2 microfarads per kilowatt of motor power. For stock capacitors, they are typically sized to be 2 to 3 times the value of the run capacitors. This larger value provides the necessary boost for starting. Lastly, understanding the effects of series and parallel capacitor connections is vital. In a series connection, the voltage across the capacitors adds up. So, the total voltage equals the sum of the voltages across each capacitor. However, in a series connection, the total capacitance decreases. The total capacitance is calculated as the inverse of the sum of the inverses of individual capacitances. For example, if you have two capacitors, capacitor 1 and capacitor 2, the total capacitance is calculated as capacitor 1 times capacitor 2 divided by the sum of capacitor 1 plus capacitor 2. In a parallel connection, the voltage remains the same across all capacitors. Each capacitor experiences the same voltage, but the capacitance increases. The total capacitance is simply the sum of the individual capacitances. So, the total capacitance equals capacitor 1 plus capacitor 2, and so on. In summary, carefully adjusting the capacitor values and understanding series and parallel connections are key to resolving the motor fan direction issue. Remember to disconnect the start capacitor after startup to prevent any damage. To calculate the appropriate capacitor size for a motor, you need to know the motor's power rating in kilowatts, the voltage, and the desired power factor correction. If you aim to improve the power factor of a motor using capacitors, here's a basic approach. Firstly, determine the motor's kilovolt amps rating. This can be calculated using the formula kilovolt amps equals horsepower times 0.746 divided by the motor's efficiency. Secondly, calculate the reactive power without correction. This is found by using the formula kilovolt amps times the sine of the initial power factor angle. Thirdly, determine the desired power factor. This is the power factor you want to achieve after correction, usually close to 1.0. Fourthly, calculate the reactive power with correction, using the formula kilovolt amps times the sine of the desired power factor angle. Fifthly, find the difference in reactive power. This is the reactive power that needs to be compensated by the capacitor, and it's calculated as the reactive power without correction minus the reactive power with correction. Sixthly, calculate the required capacitor kilovolt amps rating. The capacitor kilovolt amps is equal to the difference in reactive power. Seventhly, determine the capacitor's capacitance. The capacitance in microfarads can be calculated using the formula capacitance equals capacitor kilovolt amps times 1000 divided by 2 times pi times the frequency times the voltage squared. When connecting capacitors in series, the total capacitance decreases while the voltage rating increases. When connecting them in parallel, the total capacitance increases, but the voltage rating remains the same. The start capacitor is generally a non-polarized electrolytic type designed for intermittent use, while the run capacitor is typically a film capacitor designed for continuous operation. The start capacitor provides a high capacitance value for a short duration to give the motor the initial torque needed to start. The run capacitor, on the other hand, is designed to improve the motor's efficiency and power factor during continuous operation. When choosing a capacitor, it is crucial to consider the voltage rating. The capacitor's voltage rating must be equal to or greater than the voltage of the circuit in which it will be used. Using a capacitor with a lower voltage rating can result in the capacitor failing, potentially causing damage to the motor or other components. Also, consider the operating temperature. Capacitors have a maximum operating temperature, and exceeding this temperature can shorten their lifespan or cause them to fail. The motor's full load amps is the current the motor draws when it is operating at its rated horsepower and voltage. You can find the full load amps value on the motor's nameplate. The run capacitor helps to improve the motor's power factor, which is the ratio of real power to apparent power. A higher power factor means the motor is using electricity more efficiently. Choosing the correct capacitor involves matching the capacitor's voltage and capacitance to the motor's specifications. The capacitor should have a voltage rating equal to or greater than the motor's voltage, and the capacitance should be within the range recommended by the motor manufacturer. If the capacitor is too small, the motor may not start properly. If the capacitor is too large, it can cause the motor to overheat. In single-phase motors, capacitors are often used to create a phase shift in the current supplied to the motor's windings. This phase shift creates a rotating magnetic field, which causes the motor to start and run. Without the capacitor, the motor would not be able to start on its own. When replacing a capacitor, it is important to disconnect the power to the motor and discharge the capacitor before touching it. Capacitors can store a significant amount of electrical energy, even after the power is turned off, and touching a charged capacitor can result in an electrical shock. Always use a voltmeter to verify that the capacitor is discharged before handling it. It's also essential to use properly insulated tools when working with capacitors. Common symptoms of a failing capacitor include difficulty starting the motor running at a reduced speed, excessive motor noise, and the motor overheating. If you notice any of these symptoms, it's a good idea to have the motor and its capacitor checked by a qualified electrician. Capacitors can fail due to a number of factors, including age, excessive heat, overvoltage, and physical damage. When a capacitor fails, it can either short circuit, open circuit, or experience a reduction in capacitance. A shorted capacitor will draw excessive current, which can trip a circuit breaker or damage the motor. An open capacitor will prevent the motor from starting. A capacitor with reduced capacitance will cause the motor to run inefficiently and may eventually lead to motor failure. In some cases, you may be able to test a capacitor using a multimeter with a capacitance function. However, this test may not always be accurate, and it's often best to replace the capacitor if you suspect it is failing. Some multimeters have a dedicated capacitor testing function that can provide a more accurate reading of the capacitor's capacitance. When testing a capacitor with a multimeter, make sure to discharge the capacitor first and disconnect it from the circuit. Set the multimeter to the capacitance function and connect the leads to the capacitor terminals. The multimeter will display the capacitor's capacitance value in microfarads. Compare this value to the capacitor's rated capacitance. If the measured value is significantly different from the rated value, the capacitor may be faulty. However, keep in mind that capacitance values can vary slightly even for new capacitors. It's also important to check the capacitor for physical damage, such as bulging, cracking, or leaking. If the capacitor shows any signs of physical damage, it should be replaced immediately. Remember to always follow proper safety precautions when working with electrical components, including disconnecting the power, discharging capacitors, and using insulated tools. If you are not comfortable working with electricity, it's best to consult with a qualified electrician. For selecting the right capacitor for a specific motor application, consider the following factors. 1. Voltage rating. The capacitor's voltage rating must be equal to or greater than the motor's voltage. 2. Capacitance. The capacitance value should be within the range recommended by the motor manufacturer. 3. Type. Choose the appropriate type of capacitor for the application, such as a star capacitor or a run capacitor. 4. Temperature rating. Select a capacitor with a temperature rating that is suitable for the operating environment. 5. Physical size. Make sure the capacitor is physically compatible with the motor's enclosure. 6. Safety certifications. Choose a capacitor that meets relevant safety standards and certifications. When connecting a start capacitor in parallel with a run capacitor, ensure that the start capacitor is disconnected after the motor reaches a certain speed. This can be achieved using a centrifugal switch or a contactor. Leaving the start capacitor connected for too long can cause it to overheat and fail. Start capacitors are designed for intermittent use, while run capacitors are designed for continuous operation. Using a start capacitor as a run capacitor can significantly reduce its lifespan. The equivalent capacitance of capacitors connected in series is always less than the smallest individual capacitance. The equivalent capacitance of capacitors connected in parallel is always greater than the largest individual capacitance. Always disconnect power to the circuit before working with capacitors. Use a voltmeter to verify that the capacitors are discharged before handling them. Capacitors can store a dangerous amount of electrical energy, even after the power is turned off. Always use properly insulated tools when working with electrical components. Wear appropriate personal protective equipment such as safety glasses and gloves. If you're not comfortable working with electricity, consult with a qualified electrician. The direction of rotation of a single-phase motor can be reversed by switching the connections to the start winding. However, this should only be done when the motor is stopped. Reversing the connections while the motor is running can cause damage. Some motors are designed to be reversible, while others are not. Check the motor's nameplate and wiring diagram to determine if it is reversible. If the motor is not designed to be reversible, attempting to reverse its direction can damage the motor or other components. When working with capacitors in a motor circuit, it is essential to understand their function, characteristics, and proper connection methods. This knowledge will help you troubleshoot problems, select the right components, and ensure safe and reliable operation. A common mistake is using a capacitor with the wrong voltage rating. This can lead to capacitor failure and potentially damage the motor. Another common mistake is connecting capacitors in series or parallel incorrectly. This can result in incorrect capacitance values and affect the motor's performance. Always double-check your connections before applying power to the circuit. Another crucial point is to ensure that the capacitor is properly secured and protected from physical damage. Vibration, moisture, and extreme temperatures can all shorten the lifespan of a capacitor. If the capacitor is located in a harsh environment, consider using a capacitor with a high temperature rating or providing additional protection. In some cases, it may be necessary to use a capacitor with a higher voltage rating than the motor's voltage. This is particularly important in applications where the motor is subjected to voltage spikes or surges. A higher voltage rating will provide a greater margin of safety and help to prevent capacitor failure. Also, keep in mind that capacitors can age over time even if they are not used. The electrolyte inside the capacitor can dry out, leading to a reduction in capacitance. This is why it's a good idea to periodically check the capacitance of capacitors in critical applications and replace them if necessary. In addition to capacitance and voltage rating, another important characteristic of a capacitor is its equivalent series resistance, or ESR. ESR is a measure of the capacitor's internal resistance and can affect its performance in high-frequency applications. A capacitor with a high ESR can dissipate more heat and may not be suitable for certain applications. When selecting a capacitor, consider its ESR and choose a capacitor with a low ESR if necessary. When troubleshooting motor problems, it is important to consider the capacitor as a potential cause. A faulty capacitor can cause a variety of symptoms, including difficulty starting, reduced speed, excessive noise, and overheating. If you suspect that a capacitor is faulty, test it with a multimeter or replace it with a new one. Remember to always follow proper safety precautions when working with electrical components. Always disconnect the power, discharge the capacitor, and use insulated tools. If you're not comfortable working with electricity, consult with a qualified electrician. By understanding the function and characteristics of capacitors and motor circuits, you can effectively troubleshoot problems, select the right components, and ensure safe and reliable operation. Always prioritize safety and follow proper procedures when working with electrical components.